tour of various coordinate systems, tour what we are making in various coordinate systems, and then interoperability, and then its model along with algebra and vector. Vector, you are awesome. So we are in a phase of doing some kind of different kind of magic. Magic, it's a magic, right? It is a at the end it is a kind of magic. Okay, so at the end, whatever we are doing, so it's a kind of magic. Certainly, right? So the for the magic, whatever the example we have till now we have taken is for the sphere. Sphere is considered as one of the most complex example that anyone can take. So what we have done? So we have Cartesian coordinate system, we have polar coordinate system, we have cylindrical coordinate system, we have a spherical coordinate system. In Cartesian coordinate system, then what we have in Cartesian coordinate system? So if I talk about Cartesian coordinate system, then we have x-axis, y-axis, z-axis as orthogonal. These are the independent variable. If we talk about polar coordinate, then we have radius and angle. Okay, so polar coordinate is nothing but which works in a circle. So if I have a circle, then there is a radius. If I have a circle, then there is a radius. What is a variable in the circle? One variable is circle can be small, circle can be big. If circle can be small and circle can be big, then what is changing? The changing part is the radius if it is small and big. So radius is one of the component. Like if I have a cube, if I have a cube, if I have a cube, then what is the variable? What is the If I have a cube, then what is the variation? That a cube can be small, cube can be bigger, or I can make one side bigger. Means x-axis, y-axis, and z-axis, they are independent component. Independently, I can change it. If I take polar coordinate, then I can make circle small, bigger. So radius is changing. If it is a circle, then I can make a pi. Pi. If I can make a pi, then from here to here, whatever the cross section comes like a cake, pi, pi, pi cake. So from here, then if I go with some angle, then whatever section I'm seeing now, this section, okay, this section. So this section will keep changing. It will become, so angle is another independent component. So in polar coordinate, theta and radius is the independent component. If I go for cylindrical coordinate system, then this is a cylinder. Cylinder has a, this is cylinder. Okay, cylinder has a circular base and then perpendicular. Okay, cylinder has a circular base and then perpendicular. So this is cylinder. So cylindrical coordinate system. So cylindrical coordinate system, then we have theta and r in the base variable and z. If I take a spherical coordinate system. Okay, this is sphere. So in a spherical coordinate system, then there is no concept of kind of base radius, because there is one radius from center to the touching the kind of if there is a center, if this is centered at origin from center to the surface, there is radius A. A radius A is everywhere. So one radius A. So what variation I can see? What variation I can see in this sphere? A sphere can be small, big, 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 big. Okay. So sphere can be small, big, big, big. Okay, I have a small sphere, then bigger than this is the sphere, and bigger than this, then this is the sphere. Okay, so bigger sphere, smaller sphere, and then smaller sphere. So sphere can be, what is changing if I make bigger to smaller? Radius. So radius is one independent component. Another how independent component means what independent component they form the shape. In very crude way we can say, if I have a cube, then what forms the cube? Three sides of the cube. I mean three edges of the cube primarily. X axis, Y axis, Z axis. Cylinder, then radius and horizontal angle, and then perpendicular. Polar coordinate, radius and angle. Spherical coordinate, then radius. Because of radius, the sphere becomes big, 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 and it become football, soccer. What is the another one that on which this sphere is built upon? So vertical angle, radius is there, it's all right, but if only radius is there, it's a straight line. So radius will rotate like this, then it makes the vertical arc. So that is another component. That is the phi angle. Phi angle is varying from the vertex from the perpendicular. If I make phi angle, if phi angle is varying, can you see the this? Okay, if it is varying, it is making one side of the sphere. Another is horizontal. If it is varying horizontally like this, then theta is one independent component, phi is one independent component, and radius radius itself is one independent component, because radius becomes small and it becomes big, then sphere size changes. Phi from here to here, then this much is the kx side in 3D we get, or theta from here to here, then this much is the size I get. So three independent components. So this is what we have seen, that Cartesian coordinate system, polar coordinate system, and cylindrical coordinate system, and then spherical coordinate system. What we saw next is that we can calculate volume of a sphere, cylinder, and then sphere. We can calculate the volume of a sphere through spherical coordinate system, cylindrical coordinate system, and then Cartesian coordinate system on its own. But there are two ways. There are two ways. This is our philosophy. So there are two ways we can calculate the volume. One is dV. Inside a sphere, I take a small volume, and that volume I kind of spread over the full, or which will go along the full sphere. dV, d and v, that I have to integrate three times in three directions. So with that approach also we calculated the volume, and then fxy, function over xy, or function over r theta z, and function over r theta and r phi and theta. R phi and theta in cylindrical, r theta and z, here x y z, x x I'm sorry. So if I have a function over xy plane, function over xy plane, fxy, fr theta, here also fr theta. So if I have fr theta and fxy, so fxy, then d of the xy plane. Through that also we calculated the volume. So, but in spherical coordinate system, we did this through two ways. Okay, calculating the integration, the volume through the FR theta d the xy plane we did through two ways. One through r theta and one we did through theta and phi. So please refer to the past video. So these are crucial. Why we are doing kind of churning? We are doing kind of churning. Okay. So if you see hashish, I mean, never smoke hashish. But the poppy, okay, the poppy is a crop in Afghanistan. Poppy, okay. Afghanistan is not known for the poppy. Afghanistan is known for the dry fruits. But there are some circumstances where farmers are forced to grow poppy due to political scenario or whatever. Even they are moneyless, whatever, but farmer will never grow a poppy when he knows that people they make hashish. Poppy is not that injurious. They will make hashish of the poppy and then they will smoke it. They know it, but they will never do it. So farmer, I know farmer, this community especially I know, so they will never do this kind of cultivation when it takes someone's life. It is a kind of, it is a false statement that Afghanistan farmers they grow poppy and because of that hashish they make and it goes in international market. They are forced to do. They are forced to do. This is not for their livelihood because it is required for livelihood of the government. That's why they are forced to do. If they are doing like that. Otherwise, the farmers in Afghanistan, their main crop is dry fruit crops like grapes crops or any other kind of pomegranate, and these are world best quality. So walnut. So these are pista, then many Ayurvedic medicines, Kali Darak, and those kind of. Okay, anyway, when poppy comes up, then there is a fruit, and if you cut the fruit in the morning, then it will give the milk that you have to collect. When you get a lot of milk, it becomes like a soft. That milk will be soft. If it get dry, like a soft flour dough. If you mix water in flour, it will become like that. Then they churn it. Okay, full day one person will be there from hand, leg, whatever comes, they will keep messing with it. Keep doing it, keep churning it, keep churning it, keep churning it, keep churning it. Okay, I believe after that they place into some hot heat flame or something like that, and then it becomes hashish. So that churning we are doing in the Cartesian coordinate system so that it becomes hashish. Hashish in the sense that you start enjoying it, not in a bad sense. Someone should take in a good sense. So this way we are churning. Then we calculated. I'm saying that we calculated the volume through two ways: dv and then fxy dxy plane. In a spherical coordinate system, we did this fxy or d or f r theta and then d of the surface area again in two ways. One is with the independent component r and theta, and again in the independent component theta and phi. So please refer that. Then we calculated the surface area. So surface area in Cartesian coordinate and then in cylindrical coordinate separately and then spherical coordinate separately. We'll do surface area again today. And then we saw the interoperativity when doing surface area of the coordinate of the Cartesian coordinate. Interoperativity or hybrid model is that it is always ED to start with the Cartesian coordinate. Always easy because we know x axis, y axis, z. Who understand r, d theta, and dr, and then phi, d phi, and this. It is a spherical coordinate system from human brain. It is much more complex. Cylindrical coordinate system is little less complex. Polar coordinate than Cartesian. Cartesian coordinate is simple to at least to visualize x-axis, y-axis, and z-axis. And then you understand three orthogonal lines are there. And then in a straight line, everything comes into the picture. So that is kind of Cartesian. So person start with Cartesian coordinate and at some point he stucks. If he stucks, okay, so if the person stucks at some coordinate system at some point, if he is taking Cartesian coordinate system, and if he stucks at some point, then part of it, section of the computation, he can convert into other coordinate system like polar coordinate system, cylindrical coordinate system, or spherical coordinate system. So that is interoperability or hybrid model. So nice, so funny, so good it is. Interoperability. Please start doing everything from the Cartesian. So whatever interoperability we have done, it is our disclosable. So disclosurable. So we have done it. Okay, and then in a spherical coordinate system, calculating the kind of volume through kind of theta and phi that we have done. So in interoperability, if I go from Cartesian to spherical, and then we convert the xy plane into not one into r d theta into phi and theta. If that is the variable, then it is our way. Anyway, we have seen all the journey. Okay, now I'll proceed just with the kind of calculating the surface area in a spherical coordinate system with a spherical coordinate system, not in a hybrid model. Okay, why it is important, that should be seen slowly. Okay, so if I have a sphere, if I have a sphere, then what is the surface area of the sphere? If I go with the spherical coordinates, if I go with the spherical coordinate system, then we know that if I take, okay, like in Cartesian coordinate system, if you remember, then I have x-axis, I have y-axis, I have a function over x-axis and y-axis. Now, if there is a position vector here, if it is centered at the origin and there is a position vector p here from origin to p, if I draw a vector, then position vector is xi plus yj plus zk. Xi plus yj plus zk. If that is true, if that is p, then dp by dx is velocity vector along x-axis, dp by dy velocity vector along y-axis. If that is true, then dp by dx cross product with dp by dy gives me the area velocity vector. If that is true, then if I get the magnitude of area velocity vector, and then if I do integration, I get the area in algebraic equation. So keep changing the x and y and keep getting the area from the beginning. This is what we have communicated. Now, what is the equation we saw, that is for the, okay, so if I have xi plus yj plus zk, if it is fxy, if it is position vector, then dp by dx is I plus dz by dxk. dp by dy is j plus dz by dy k. If I do cross product, it becomes minus dz by dx I minus dz by dyj plus k. If I calculate the magnitude, then it becomes dz by dx whole square plus dz by dy whole square plus 1 square root, where z is fxy. Now, if I go, so I can call it as fx square plus fy square plus 1 square, where fx is dfxy by ds, partial derivative. If that is the case, now let's see the kind of spherical coordinate system. So here the three coordinates are theta, phi and radius, not x, y, z. Now what is the equation of the kind of, if I am looking for, what I am looking for, fx square plus fy square plus 1 x and y. not z, fx square plus fy square plus 1 square root, where fx is dz by dx, where x is dz by dx. What is fr theta? Now, if I take xy plane in a spherical coordinate system, then there is a r, not I am talking about full A radius. I am not talking about full A radius. Or I can consider in other way. If this is centered at origin, if this is centered at origin, and at the equatorial, if I make a cut xy plane, then it will be a circle of radius a. That is the radius of the sphere at equatorial. Now, if I go little up and if I make a cut again there will be a circle. And the end of the circle, if I draw a line from the origin, then that is the radius of the sphere a, where the circle radius is r, that is variable as we change the height, and height is z. Okay, then what is the z equation? Z equal to r square plus a I mean z equal to a square. A is the radius of sphere. A square minus r square square root, where r is variable, a is not variable. If r is changing, if I make cross section at different height, if r is changing, z is changing. This is the formula of f. Now fr theta. If this is xy plane and r and theta are two independent variables, f r theta. If f r theta, now f r theta is square root of a square minus r square. This is the algebraic equation which has no dependency upon theta. So angle does not matter as when height comes. Only the radius matters. If radius keeps changing, then height will keep changing. Doesn't matter the theta angle. So fr theta and d of the xy plane, that is r d theta dr. So now we have fr theta as square root of a square minus r square. It looks little tedious. That's why I thought bringing it up again. Now, what is the velocity area magnitude? Square root of fx square plus fy square plus 1. So the function is r a square minus r square square root. First we will derive with the dr. dz by dx, dz by dy. Here dz by dr, dz by d theta. So dz by dr, square root of a square minus r square by dr is, if I do differentiation, it will come as minus r divided by square root of a square minus r square. Now square root of a square minus r square d of d theta. Theta is not there, so it is 0. If that is the case, then velocity area magnitude is square root of fx square plus 1 square. So that is r square, square root of, so r square divided by a square minus r square plus 1 square. That will come as a divided by square root of a square minus r square. A divided by square root of a square minus r square d of the xy plane. I will get the surface area. So what is the d of the xy plane? If we want to calculate, so d of the xy plane in the sphere, d of the xy plane in the sphere is nothing but r d theta dr. That is the where we calculate the xy plane area. So now a divided by square root of a square minus r square, r d theta dr. So r dr d theta. So a I can keep outside. Then 1 by a square root of a square minus r square, r dr d theta. So r by a square root of a square minus r square integration I have to calculate. That would come as minus 1 by minus square root of a square minus r square minus square root of a square minus r square. Okay, if I do differentiation of this, then it will turn up as 1 by a square root of a square minus r square minus okay half minus square root of a square minus r square. Differentiation is minus, I keep outside. Then it is half 1 by square root of a square minus r square minus 2r. 2 gone, 2 gone, and then minus minus gone, r by square root of a square minus r square. So it's perfect. So minus square root of a square minus r square is the integration. So now this integration, the radius, we want surface area. So radius from 0 to a. We are calculating for the hemisphere, mind it. So 0 to a. So a square minus r square, 0 to a if I do, okay, where minus a is outside. Now minus is also outside, minus a. Now minus a, now square root of a square minus r square. So from 0 to a means 0. 0 means a. A square minus 0 is a. Okay, but it is lower limit, so minus gone, and a square. Okay, so it is a square. Now d theta integration 0 to 2 pi. Theta moves like this in xy plane. Okay, radius moves like this in xy plane. So 2 pi. So 2 pi a square is the surface area of the hemisphere we calculated, because fxy or fr theta we have taken for the x above the xy plane, multiplied by 2 pi 4 pi a square is the surface area of a sphere. Okay, so this is kind of everything, all permutation combination from placing seed inside the ground for the poppy till it comes up, then we cut it, make a chira, we cut it, milk comes out, then collecting the milk to finally churning it heavily to finally to roast it and finally making it the hashish. It's not a good thing, but this hashish is good, so that it will give you enjoyment. So full, all four Cartesian coordinate, everything we have done now. Okay, so now the question is arising, the scenario is arising. We had given one questionnaire. The questionnaire is, if I have a tank, if I have a water tank is hemisphere. Water tank is hemisphere. Water tank is hemisphere. If water tank is hemisphere in the sense, if I cut this into half, if I cut this into half, then there is a hemisphere. Water tank is hemisphere. Water is filled up to a level. Water is filled up to level. Height is h. If height is a is the radius of the sphere. If water is rising till a, then tank is full. But water is rising till height h only. Then what is the volume of the water that hemisphere or water tank contains? This is a questionnaire. Now answer to it, we tried first finding out through the cylindrical coordinate system. So in cylindrical coordinate system, if I want the kind of to calculate the volume, cylindrical coordinate system, again we can do in two ways. Cylindrical coordinate system we can do in two ways. Two ways in the sense that we will have dv, small volume, and dv we will have triple integration. Okay, dv will have triple integration. If dv has triple integration, what is dv? A small volume inside a cylinder. If I have a cylinder, then what is the formula for the one small volume? The volume for a cylinder is nothing but the surface area into the height. Volume of a cylinder is pi r square into height. So volume of a dv is also pi r square into the height. Okay, so if I take r as any r from origin to r, where if it goes maximum, then it becomes a, that is the surface. So the sphere, okay, sphere, we are taking cylindrical coordinate system. Sphere is inside the cylinder. Okay, so this is cylinder. This is cylinder. Then we are calculating the volume of a hemisphere. Okay, where water is at height level h, where sphere is exactly touching the surface of the cylinder. Now consider this cylinder. Okay, through cylindrical coordinate system, we will calculate the volume of a hemisphere. Now, if I take a small volume inside the cylindrical coordinate system, if this is the radius, or consider this is the radius of the base, then from here to here it is a. That is the radius of the sphere, because the sphere goes and fit there exactly. Then if I take from 0 to r any small radius, that will go till a. So that r, if I take, then what is at, okay, so I am here inside the cylinder. At any location I have a small volume v, dv. So that small volume dv inside there, from origin it is, from origin it is at r distance, as far as radial distance is concerned. So what is the volume? Volume is r d theta dr, that is the horizontal area, and height, that is the z, whatever z we are taking, r d theta into z, r d theta into z, that is the volume. I'm sorry, r d theta is the arc, r d theta dr and z. This is the dv volume. So dv now change into r d theta dr dz. Now triple integration. Now r radius is varying from 0 to a. The angle is 0 to 2 pi, and z is 0 to h. H. But there is a caveat here. Radius is not here. If I take cylinder, then radius is same as what we see at the lower level and higher level. That is the cylinder. But we are calculating for the sphere, where at the equatorial radius is a, but radius is keep on decreasing, and it is making the sphere. So radius is in variation with the z. So radius, I cannot take 0 to a. 0 to a radius, I have to take 0 to variation with the z. Now I have done the calculation. Now if I cut this sphere at any height, and there is a circle again, that radius is r and height is h, then this diagonal is a, that is the radius of a sphere. So h, so r equal to a square minus h square. So h is varying, then r is also varying. So a square minus h square, the square root is the r. So r, if I place limit, then 0 to square root of a square minus h square. Theta 0 to 2 pi, full it will make. Z is 0 to h. Okay, that much. Now r d theta dr dz, r dr d theta dz, r dr, if I do integration r square by 2, that will come as a square minus h square by 2, then into d theta is 0 to 2 pi, then it is 2 pi 2 gone, pi I'll keep outside. Now okay, now it is, okay, now it is a square minus h square dz. It will become a square z minus a square z minus h square. Okay, so h is variable, h is the height, and it is variable. Now let term h as z. So from 0 to z. So now we have a square minus z square dz is the integration. So a square z minus z to the power 3 by 3. Limit is 0 to h. This is better. 0 to h. So a to the power a square z minus z to the power 3 by 3. Outside is the pi. So that is the one. So a square. So if I place 0 to h, then 0 is no value here, h. So pi into and braces a square h minus h to the power 3 by 3. Okay, that is the volume of the water at level height. Okay, what is remaining? Someone can try this through functional way. We calculated the volume through dv, whatever through fxy dxy plane. That is one thing. Then, since it is a sphere, then this water tank height, volume, water volume should be calculated through a spherical way also, spherical coordinate system also. Someone can now calculate through a spherical coordinate system and then come up to us. Okay, our number, telephone number is 9483160610610. 94831606110. Country code of India is 91. So now you can solve this through fxy dxy plane in the cylindrical coordinate system and through all the possible way into the spherical coordinate system where hemisphere is a water tank and water is at level height h, where a is the radius of the sphere. Then what is the volume of water inside the hemisphere? Through three ways we expect, in one in cylindrical and two in spherical coordinate system, that is expected, and we will see what would be the solution.